So let's go over some examples of conversions. And I'm going to take the examples from your homework set, and we're going to start off with one example where we were looking at the speed of tectonic plates. It's actually not that relevant. What we're mostly interested in is, we're looking in this case at a speed, and you may all have been given different numbers, but I'm going to put 3.4. There was centimeters per year. It was a two-part question. And part A, we wanted to find the distance that it moved in 1 second. But we wanted that in nanometers. So we were looking for the number of nanometers in 1 second. So in other words, a way to figure this out is to actually convert the speed that is in centimeters per year to a speed in nanometers per second. All right, so nanometers per second will tell us how many nanometers will have traveled in 1 second. The second part was to figure out what the speed would be in kilometers per million years. Okay, so we're going to start off by looking at part A and see how we can convert the speed and go from centimeters per year to nanometers per second. So we have two parts. We have to deal with centimeters, and we have to deal with the year, the time. So we have to convert the distance and the time. You can start with either, but I'm going to start with the time piece, which is the year. So we want to find out essentially how many seconds we have in 1 year. And so we can break it down. There's multiple ways to approach this, but I'm going to do this in steps. And first step, I'm going to say that in 1 year, I know that we have about 365 days. Okay, so this is typically what we describe as a conversion factor because it allows us to convert. So in this case, go from years to days or the other way around, depending on what we're solving for. So in this case, I want to convert my years to days. So we're going to see how that's going to be relevant in a second, but I'm going to rewrite this and say, okay, so this is actually equivalent to saying that 1 year over 365 days is equal to 1. So that in itself does not make much sense. All right, so why would we do this? It's going to become more obvious in the next step. Okay, so in the next step, I'm going to say, all right, so now, and this is in days, but I just want to show you how to get started. And then we know that we can count the number of hours in a day, and then the number of minutes in an hour, and finally the number of seconds in a minute. And that will give us what we're ultimately looking for. But let's start with this. So if I'm writing 3.4 centimeters per year, I can rewrite this as centimeters per year this way. And you can see that the goal is to get to something, at least in this step, that's going to look like centimeters per second. So we want to get rid of year here, and we want to replace that by second, but we're going to do this in steps. So we're going to actually multiply this number by 1. So we're allowed to multiply this by 1. It's not going to change anything, right? But we know that 1 is actually equivalent to this fraction. So I can multiply by 1 year over 365 days. All right, so let's pause for a sec here and see why exactly I'm doing this. So it may actually be more obvious why exactly I wrote this part now and why I didn't actually choose. I could have said, okay, 1 is equal to 365 days per year, which is correct, but it's not what is useful here, because you can see that by multiplying by this number, I can eliminate years. And at this point, that means that if I were to multiply, so to take 3.4, sorry, and divide by 365, I would have my speed in centimeters per days, which is a step closer to what we're looking for. So we're not quite there yet, because we don't want centimeters per days, we want centimeters per second. So using the same logic, we can essentially multiply by another 1, but one that will allow us to convert our days to hours. So I would actually encourage you to pause the video at this point and try to fill in, what is the next step here. And you can see the goal here is to eliminate days and introduce, so we're going step and figure out hours first. All right, so you can pause and try to figure it out now. So, okay, so how many hours in a day? It's going to be 24. So in one day, and if you want, you could go back to this step and do it this way and breaking it down this way. It may seem very lengthy to do it this way, but as you're learning how to do this, it's actually a good step to continue doing. And you'll see that eventually when you do it enough, it will just become second nature and you won't have to do this step anymore. But we have in one day, 24 hours. Okay, so this is for HR. I'm going to put that for hours. So this is good because you can see that now I can eliminate days, and I'm going to have something in centimeters per hour. I'm going to go through the next step quickly, but I encourage you again to pause if you want to fill it out for yourself first. So now I'm going to eliminate the hour, and I'm going to figure out how many minutes I have in 1 hour. So that's going to be 60 minutes. Okay, and you can see that again, writing it this way, I can eliminate the hours, and we are almost there, because now we have to look at how many seconds in a minute, and we know that we have 60 seconds in a minute. And you can see that at this point, we are happy because we have seconds here. So this is still in centimeters, but that is essentially what we were looking for. So that means we're going to have our 3.4. So if I should have left a little bit more room here. So let me actually erase this real quick. But this was the goal, and I'm going to rewrite that. So 3.4, and I'm going to leave the units at the end, but I'm going to take 3.4, and you can see that I have to divide my 3.4 by 365. I'm also dividing by 24, 60, and another 60. All right. And then my units will be centimeters per second. So at this point, you can plug that into your calculator and take a look at what it looks like. So it's going to give you something that is about 1.078 times 10 to the negative 7 centimeters per second, which is not our final answers because again, we are looking for the number. So we know we have the number of centimeters in a second. So what we're going to see now is that we know that centimeters are going to be 10 to the negative 2 meters. So we have to divide, in other words, by 100. So another way to look at this is that we can multiply this by 10 times 10 to the negative 2, which is the same as dividing by 100 to convert that to meters. And so that would mean that, and again, there's different approaches for this. So if you're doing it differently, that's absolutely fine. But that's 10 to the negative 9 meters per second. The reason I wanted to highlight this is that right here, 10 to the negative 9 meters is actually 1 nanometer. So that means that our final answer is going to be 1.078 nanometers per second. So that is your answer. You probably don't need to keep so many significant figures, so you could probably round this to 1.08 instead. So that means 1.08. So let's say this would correspond to, in your final answer, about 1.08 nanometer in 1 second. All right, really quick. Let's do part B. So in part B, we were now looking at changing that to kilometers per million years. All right. Okay, so let's see. So we're going to start off again with our 3.4 centimeters per year. Okay, so we can look at how many centimeters, how many kilometers that is going to correspond to. So in 1 kilometer, we have 1,000 meters, so 10 to the 3. But we don't want meters here, we want centimeters. So again, looking at all of your, you know what, the kilos and the centis and etc. That would be 10 to the 5th centimeters. Okay, because we have 100 centimeters in a meter. So again, using the same method that we did here, and this time trying to replace our centimeters by kilometers, right? The goal is to have kilometers here, centimeters here, so we can eliminate that and have kilometers. And what we see is that in 1 kilometer, we have 10 to the 5th centimeters. So make sure we stay, you can see. So that's going to be equal to 3.4 times 10 to the negative 5 kilometers per year. Okay. Okay, so now we were asked per million years. So I'm gonna do my little trick again and see, okay, so what is a million year? It's 10 to the 6 years. So 10 to the 6 years for 1 million year. Okay, so that allows me to get rid of this. And we're going to get our final answer. So it's 10 to the negative 5 times 10 to the 6. So that's going to be the same as multiplying by 10. So that gives me 34 kilometers per million year. All right, so thank you for your patience, but it's was really broken down in steps. And again, you could do this a lot quicker, or even write down more steps as needed. But I just wanted to make sure I would break it down in steps for you. But if you do have any questions, please reach out and I'll happily go back and answer your questions. Thank you.